All right, the second part of section 1 talks about linear equations in two variables in what we call standard form. And an equation that can be written in standard form is written with your ax plus by equals c, where a, b, and c are real numbers. So you have a coefficient before the x term, coefficient before the y term, and then your constant is on the other side of the equal sign. Also, you need to note that a and b are not equal to 0. So this particular form of a linear equation with two variables, these are your two variables, x and y, because don't forget a, b, and c are numbers, is what we call the standard form of a linear equation. And the benefit of having a standard form of a linear equation is that we can graph in standard form using x and y intercepts. In other words, we graph by finding where the line crosses the x-axis and where the graph crosses the y-axis. And again, once you have 2 points, all you have to do is connect the points and you have your line graphed. So let's talk about how to make that happen. Let me erase here. I'm not sure how far down you guys can see on the board. Okay, so to find the x-intercept in standard form, what we do is we substitute 0 for y and then solve for x. To find the y-intercept, we substitute 0 for x and then solve for y. So it's pretty straightforward once you manipulate your equation into standard form. So let's look at an example. Let's look at x plus 2y equals 0. And we want to find the x and y intercepts, and then we want to graph it. Okay, so to find the x-intercept, what we're going to do is we're going to substitute 0 for y here. So we'll have x plus 2 times 0 equals 0. X plus 0 equals 0, so x equals 0. To find the y-intercept, what we're going to do is we're going to substitute 0 for x, so we'll have 0 plus 2y equals 0. 2y equals 0. Divide both sides by 2, and in this case, y also equals 0, so they intercept at the same point. Now, this one I wanted to show you as an example is sort of an anomaly because you have to have 2 points to graph a line. So we know that we have the point 0, 0, and we know that we have the point 0, 0. We got that from here and from here. We substituted 0 for y, we got 0 for x, so both are 0. We substituted 0 for x, we got 0 for y, both are 0. Again, you need 2 points. So what you can do is pick an arbitrary number for x and then solve for y. So let's say that x is 1. When x is 1, you have 1 plus 2y equals 0. Subtract 1 from both sides, so 2y equals negative 1. Divide both sides by 2, so y equals negative 1/2. There's a second point that you can graph. And now that you have 2 points, you're in good shape. So to graph this, you have your x-axis, your y-axis. Your first point is 0, 0. Your second point is negative 1, negative 1/2. So it's about here. So you just connect the dots. That's supposed to be a straight line Clearly my art skills are not very good. But anyway, so there's your graph. Okay? And then the last piece of section 1 talks about a midpoint formula. And a midpoint formula deals with the midpoint, or finding the coordinates of the midpoint of a line segment. Because when you have a line segment on a coordinate plane, or coordinate axes, it's difficult to sort of eyeball the coordinates of where the center of that line would be. So there's actually a formula in the textbook that we can use to find the coordinates of the midpoint of a line segment. And that formula looks like this. The coordinates are x1 plus x2 divided by 2, y1 plus y2 divided by 2. Now, if you look at this closely, this business right here will actually yield your x-coordinate of the midpoint. It's just the average of the two x-coordinates for your two ordered pairs that you're looking at. This business right here will yield the y-coordinate of the midpoint. So for example, if we had the line segment with endpoints P, 4, -3, and Q, 6, -1. What that looks like on a graph, and don't forget this is a line segment, not a line that goes on infinitely. We have a point at 4, -3, so 1, 2, 3, 4, 1, 2, 3. It's about right here. And this P is an arbitrary letter just naming the point, so we're going to call this point P. Q is at 6, -1. 1, 2, 3, 4, 5, 6, -1. This is point Q. So we're looking at this line segment right here. The question is, what are the coordinates of the midpoint of this line section, or segment, excuse me. So, since this is our first point, and each point has an x and y coordinate, we can label this as your first x coordinate, your first y coordinate. Second point, so x2, y2. Again, each coordinate has an x and a y. This just happens to be the first one. This is the second one. Just as a note, whichever one you label first or second is arbitrary. It doesn't matter if you label this as your first, this is your second. If you do the math correctly, it should end up as the same coordinate. No big deal. So, here, the midpoint is going to be x1, which is 4, plus x2, which is 6, divided by 2, y1, which is -3, plus y2, which is -1, divided by 2. 4 and 6 is 10. 10 divided by 2 is 5. -3 and -1 is -4, divided by 2 is -2. So the coordinates of the midpoint of this line segment is 5, -2. 1, 2, 3, 4, 5, down 2. And had my art been better, that looks about right. Okay. If you have any questions, go ahead and jot them down, and I'll be happy to answer them next week in class.